Morning, everyone. So we will actually look at this particular question. This particular question is taken from paper 5. Okay, uh, they have um, they have given you some information. Okay, and then I have actually highlighted some of the information that is considered to be very important over here to do this question. They have mentioned that the reaction is going to be a first order with respect to sucrose. And they have mentioned about there is a mathematical relationship for this equation. You have some kind of a mathematical equation. Now I took that mathematical equation and I actually pasted over here. So later we can actually compare, but here they actually mentioned that process the results to allow you to plot this graph against time. So this is going to be your y-axis and this is going to be your x-axis. And then they ask you to calculate and actually record it to 1 decimal place. One decimal place. And this one, they want you to record to 2 decimal places. So take note, it must be according to the decimal places that they are asking. Now, you have this optical rotation, and then they want you to fill up this data minus optical rotation final. This is the optical rotation final. And what I'm going to do to fill up this data is going to be 39.9, 39.9 minus, this one, if I want to actually complete, is 39.9 minus negative 12. So it's 39.9 plus 12, you will get 51.9. I have completed this. Probably I'll actually ask 2 of you to complete these 2 parts. Maybe Aditya, you do 1. Nicole, can you do this part? Nicole, Aditya. Nicole, are you here? Yeah.
22.6.
Okay, 22.6. Okay, someone else, maybe Elvin, can you do for Nicole? Help for Nicole.
7.5.
Okay, so fast. Anyway, so that's 7.5, is it? 7.5. Can someone actually help me to calculate the log 10?
Log 18.2. 1.26.
1.26. We need 2 decimal places. So I think let me double check. Yeah, 1.26.
Bingo.
Can you actually check? This one, 7.5. When you put the log, do you get 0.88?
Yeah, 0.88, correct.
Yeah. So make sure, the important thing over here is to make sure that this is 1 decimal place. 1 decimal place. And this one is recorded to 2 decimal places. That's very important. Once you get that, they ask you to plot a graph, on page 9, and use the cross. This one, I have seen many times students still use the dot. You see, they are really particular about that. Even in the question, they are already asking you to put the cross over there. So make sure, you put the cross over there. So I copied this data, whatever data that you require. The time is going to be the log value, then against the time, I've copied and put it over here. So you have a look. I have plotted the graph. And I will get some kind of a straight line graph. You can see over here. I maybe you can have a look over there. You will get something like a straight line graph. But of course, when you are drawing, try to actually get a best fit graph. You can see some of the parts, they are not fully joined. So try to actually get a best fit graph. And then I'm going to move on. They actually ask over here, state and explain whether the results in your graph confirm the relationship of this. The equation is going to be, if I copy the equation over here, let's say I'll just copy this equation. They're asking whether it confirms that graph or not. Okay, so here this is going to be, this was your, okay, this was your y-axis, okay, and this t was your x-axis. So we know that according to your maths, okay, this is mx plus c. Okay, so
Yes.
yeah, so if I rearrange this, I'm going to get negative k over 2.3, okay, and then t plus a. Okay, if you compare, okay, this is similar to what we are getting. So this is the gradient. Okay, this is the gradient, and this is going to be your y-intercept. Okay, and then that's going to be y. So you see here, there is a y-intercept here. Okay, there is a y-intercept, and all the points are within the straight line graph. So in this case, okay, whether the results is actually telling us, okay, it complies or confirms the relationship of this equation, the answer is yes. Okay, and you can actually just say that all of the points, okay, are on the straight line. Okay, so basically we are just telling that there is a straight line graph. Okay, straight line graph. But you need to mention that all the points are on the straight line. You can see there is no anomalous results, no anomaly. Okay, so everything is straight. Okay, now here, okay, determine the gradient of the graph. Okay, if you want to determine the gradient of the graph, they want you to show, okay, the coordinate that you use for the calculation. So what I did was, okay, you can see the big triangle over there. The bigger the triangle that you take, the more accurate is your gradient. Okay, don't go and calculate using a smaller triangle. So what I did was I just selected this point, okay, this coordinate, okay, the one that I already plotted earlier. And I have, I did, for this part, I didn't collect the data that I plotted. I collected somewhere here. Okay, then I draw, okay, to show the triangle. So when I calculated, I found out that this one I took at 1.61, and this one is I'm taking from 0.9, and this one is 300 when I calculated. Okay, when I look from here, it's 2,600. So they want you to actually write down the coordinates. So the coordinate is going to be x and y. So the first coordinate is 300, and then the coordinate for this is the first coordinate. This is going to be the second coordinate. First coordinate is going to be 300 seconds, and it's 1.61. And then I'm taking for the second one is going to be, I'm taking for 2,600 second, and then 0.9. Okay, you can actually choose your own coordinates. Okay, but the answer will be based on the coordinates that you are choosing. Okay, so find the gradient. Okay, there is a formula, but basically how to find the gradient is going to be y divided by x. Okay, this is y, this is x. Okay, so I found the gradient, and I know the gradient is negative gradient. Okay, it's a negative gradient because it's going to the left. Okay, so I will get this value. Okay, in the answer key, okay, they put the gradient as positive, but okay, if you give it as negative, no problem. Okay, no problem. The gradient is a negative gradient, but make sure, okay, you are going to get actual whatever value y divided by x, you must actually get that value. So you shouldn't have any mistake on over there. Negative shouldn't be a problem. Later we will actually cancel the negative. I hope you understand this part. Yeah, so if it is y and x, okay, if you have this, if you have a straight line like this is gradient is going to be positive. Okay, if you have like this, y and x, and then if you're going this way, so this one, the gradient is going to be negative. Now, so they ask you to use the gradient value, okay, to calculate the value of k in the expression shown just now. I also wrote for you the y equals to mx plus c. So if this is y, this is going to be your x, okay, x-axis. Okay, so the gradient, okay, is going to be represented by this. Okay, so my negative value, is equals to negative k over 2.3. That's when my negative I'm cancelling. K, you will get a positive value. Now I just show you the answer given here. Okay, that's why just now I told you something to do with the negative value. You see here, they actually mentioned that, okay, the K of candidate's gradient, if the gradient you are given positive, okay, then if you take the positive value times by negative, then the answer should be negative. So the answer key is not so accurate. Okay, it's supposed to be, you supposed to get a negative gradient here. Okay, they didn't mention must be negative. Okay, but you must get a negative value. Once you get a negative value times the negative value, you're supposed to get a positive value. You must get. Okay, but what happens if you get a different sign and so on? I don't think so they are going to deduct marks over here, because they didn't mention that you must deduct marks over here. But let's actually follow what we supposed to do. The one that you're supposed to do is make sure that the gradient that you take is going to be a negative gradient, then the k is supposed to be, the actual answer is supposed to be a positive value. Okay, a positive value of k. Now, the next question is, okay, the graph below shows the results obtained from second hydrolysis of sucrose reaction performed at different temperatures. So it means they still do the hydrolysis. It's still going to be, just now if you refer to the question, they say it's a first order reaction. Okay, it's still going to be a first order reaction. But the earlier graph is actually going to be something like a log, okay, something over time. Okay, so if you look at the graph, okay, I've written the graph over here. If you have, okay, if you have something like this, okay, if you are looking at the rate, okay, if you are looking at the rate, if you have a straight line just like that, okay, it's going to be first order rate versus the time. But okay, if you have concentration versus time, okay, and then you are going to get something like that, that's going to be a zero order. Okay, so here what you have over here is you are going to get a curve. So the moment you see the curve, this is going to be, that's why the curve is going to be the first order over here. Okay, so here I just want to show you this is going to be some kind of a first order reaction. Okay, first order reaction. Now here they say that, okay, the time over here, which is this one, is considered to be anomalous. Suggest what caused the anomaly. Okay, what might cause the anomaly? Michelle, what do you think? What do you think might cause the anomalous result?
Wrong reading.
Wrong reading. Actually, the answer key is very specific. You know that this is going to be the optical rotation. Okay, this is the optical rotation. And you can see the optical rotation. If let's say my value over here is slightly higher than what I supposed to obtain, I supposed to obtain something smaller. Okay, so if you look over here, if it is slightly higher means, okay, this value is higher. Okay, this value is higher. So it means that, okay, I took one of this reading more than what I supposed to take. And if you look over there, okay, the previous reading is actually bigger than the next reading. So what happened if I supposed to take the value, the reading at 1,800 seconds? The problem might be the wrong reading would have been taken probably slightly earlier than expected. Maybe at 1,700 seconds, you took the reading happened to be slightly bigger than 2.4 or something like that. So the answer key is very specific. If you just mention that it's a wrong reading, you don't get the mark. Okay, here basically you need to process saying that, oh, the rotation is higher. Then you need to still process. Okay, and what caused the anomaly? So you just need to tell that this rotation was taken too early. Okay, it was taken too early. I can show you the answer key. They didn't. They only give that value. Okay, you see, it was recorded too early.
Okay.
So cannot actually say wrong reading, problem in let's say when taking the reading or something, you must actually give the actual reason. Okay. Now, the next, okay, the next is going to be use the graph, okay, to determine the half-life of this reaction. Now, just now I mentioned that this is a first order reaction. First order reaction, you can actually determine the half-life if this is going to be the earlier concentration, let's say 1, for example. If you can actually calculate for 0.5, for example, here, that's going to be your half-life. From here to here, that's going to be your half-life. So here, if this is going to be, okay, if you look over here, but I took here so that it's easier for me to calculate. Okay, I took from here 40. So of course I need to take for 20. So I took for 20 over here. And when I bring it down, this is 40. And when I bring it down, it's going to be 700. I think it's 720. Okay, 720. Each small box is 40. Okay, 720. So my half-life, okay, is from 40 to become 20. Okay, you can see it's going to be from 720 to become 40. So it's supposed to be 720 minus 40, and I will get the half-life. Okay, so the half-life is 680. But of course, they are asking you to show the coordinates. So I'm showing the coordinate that I've taken. So I took from 40 seconds, okay, 40 seconds, and then 40, okay, I took 40. So you just need to show the coordinates. Okay, the half-life, I'm going to get 680 seconds. Now have a look at the marking key. Okay, the marking key, they don't give you the actual value. They just tell you what you're supposed to take, whatever value that you took, then they will give you the value. So it's okay, okay, if you are not getting the actual value that I have over here. Now, after that, okay, first order reaction, do remember this formula, okay, involving the K or the rate constant can be only used for first order reaction, okay, first order reaction. And we know that this is a first order reaction. So they are asking you to find out what is the K, the rate constant over here. So you found out the half-life, just put the half-life over there, find the value of the K, and you will get this value, okay? You will get this value. Now, if you have been unable to determine the half-life of the reaction, it means you still couldn't actually answer this question, you couldn't answer this question, you don't have time. Do remember sometimes, okay, they do give you this statement over there. You can actually use, for example, the value of half-life is 500. But take note, the 500 is not the correct answer. So you can see 680 and 500, there's a lot of difference, okay? So if, let's say, you don't have time, okay, if you didn't actually do, or you don't have any confidence in your answer for the half-life, you can actually use the value that is given over there. Now, if you're not talking, just mute. Okay, who's that? All right, let's move on. Okay, now here, okay, state whether the temperature of the second reaction, okay, was higher or lower than that in the first. Okay, and they ask you to use the reference of the answer from C2 and D3. Okay, C2 and D3. So this is D3. C2 is going to be somewhere here. Now, what they ask you to refer is basically the K value. The first reaction, the K value is 7.1. So I've actually taken the value and I put it over here so that we can actually discuss fast. The first K value is going to be 7.1. Second reaction is going to be 1.02 times 10 to the power of negative 3. Now, what can you say if you compare the second reaction, the K value, is it higher or lower? Justin, if you compare. Justin. Okay, never mind, we'll call someone else, okay? Brilliant. If you compare the K values, okay, if you compare the K value of the first and second, which one do you think is the higher value?
I don't know, sir.
No, you can just look at these values. I already took the value out for you. 10, -3, and 10, -4. Which one is bigger?
You call me, sir. I was in the toilet. Sorry.
Oh,
Okay.
That's Justin.
Yeah, Justin. Which one do you think is actually a bigger value? 7.1 times 10, -4 or 1.02 times 10, -3?
1.02 times 10 to the -3.
Yes. This is going to be a bigger value. So now, if you have a larger K, okay, do remember the rate constant, okay, is only going to be affected, okay, by temperature, okay. So here, the rate constant over here is going to be higher, okay. So we can actually say that, okay, the second reaction, okay, the temperature is higher because the rate constant is higher. Is that okay? So they want you to refer to the value and then ask you whether which of that, okay, will actually what is going to be the relationship of the temperature towards the rate constant. Okay, the rate constant, okay, is higher, okay, if the temperature is higher. So that's why they actually have that. Now, will the value of the half-life, okay, change if the reaction was repeated twice the initial concentration of sucrose? And give a reason for your answer. Okay, I'll repeat again. Okay, do you think, okay, if I have, okay, we are talking about this particular reaction, right? Because it's a first order reaction. They're asking you, okay, if you're referring to this, or if you want to refer to the here also can. They're asking whether, okay, if you increase the concentration or double the concentration, will it actually make, okay, will it actually make the half-life to be changed? What do you think?
No change.
No.
Why?
Because K changes if the temperature changes.
Good. Okay. You K only changes when the temperature changes. Or if you want to actually use the formula also, just now they give you the formula half-life. Okay, you can see over here half-life, and then you have this formula and this formula. This is only for the first order reaction. And take note, K doesn't change. If K doesn't change, it means that the half-life is going to be the same. Okay, the half-life is going to be the same. So here, okay, you can see that, okay, the K value, okay, it remains constant, therefore the half-life remains the same. So here I wrote over there, K is only affected by temperature, half-life will not be changed, or just say it's going to be first order. Here they actually give different answers over here, but they say that half-life will not change, okay, and you need to tell that half-life is independent of concentration, or you can just tell half-life is only affected by temperature. So here the reaction is first order. So any of this, but make sure that you need to mention about this statement and one of this statement. Okay. So if you just give only one statement, the half-life will not change. You will only get 1 mark. So it's going to be 2 marks question. So you need to explain it clearly. No, it's only 1 mark. Okay, so it means in order to get that 1 mark, you must have that 2 statement. So be careful with this, okay, because they actually ask 2 questions. Okay, give a reason and whether they will change or not. Okay, is that clear?
Yes.
Okay, from the same paper, okay, I'm discussing the second question. Generally, second question is more difficult than the first question. So I gave you the first question as your homework. So what I want you to do is you complete the homework, okay? And I will actually upload this classwork answer in your AIS. Is that okay, guys?
Okay.
Yeah. Okay, if you have any question, you can actually ask me now before we end today's section. Okay, if no question, then that's all. Thank you, guys. Okay,
Thank you.
bye. See you.
Bye, sir.
Yeah.
Bye, sir.
Thank you, sir.
Bye,
Bye,
sir.
sir.
See you. See you. Bye. Yeah. See you. See you.